Okay, in the last video I talked a little bit about how we could take this reaction and end up with these reactants and what the change in energy, or maybe it would have been better for me to have said what the change in heat for this reaction would be, right? And we came out at this answer here, 2057 kilojoules per mole of propane, right? So for every mole of propane, I'm going to release 2057 kilojoules. Maybe when we have time, when I have time, and there's not a test breathing down my neck, I will look up about how much propane that would be, but calculate it. Here's what I'm going to do. Now I want to say, let's take 100 grams of water as our starting point for our calculations. In other words, I want to generate 100 grams of H2O. How much propane would that take? Okay, so I'm just going to dial this back a little bit here first, so that I can borrow some of these numbers, and I'm actually going to get rid of some other things I don't need really so much anymore. So I don't need that. And so let's take a look here. I've got, I said my change in heat for that reaction was equal to negative 2057. I'm just realizing now as I write this that I wasn't paying very careful attention to sig figs, but you'd want to on an exam. Okay. All right. So that's the energy I'm dealing with, and the amount I want to look at is 100 grams. Well, what did I say earlier? I said that this 2057 kilojoules per mole, okay, was well, I'm going to say something circular, I guess. This is for 1 mole of propane. And I first of all, to know what this ought to come out to, I should say how much is a mole in grams would be a good thing to know, right? Or I could do some conversions, and that would be pretty useful. I could say, look, there are 4 moles. I don't know, I put a slash there, hang on. There are 4 moles of H2O for every 2057 kilojoules of heat in a reaction, right? Now that's a good ratio to know, but that's not really a great conversion factor for me at this stage. Really, what I need to do is say I've got 100 grams of H2O, right? So let's start with that, and I'm going to run this just like a unit conversion, and it should come out pretty simply. So let's do it. I've got 100 grams of H2O as my starting point. Okay. And, well, I want that to be seen in joules. Well, I know that there are 4, or yes, I do have joules. I know there are 4 H2O moles per every 2057 kilojoules of energy released in this reaction, but I would really want to know it for 4, let's just erase that part here. It's getting confusing, okay? I want to know what it is for this 100 grams of H2O. So I'm going to draw this little line right here because it just helps me to think better, okay? Now I'm going to say, let's convert that. I think moles would be useful to know right at this point, right? But to do that, I'm going to need to know the molar mass for H2O, right? So let's do that. That could be pretty easy to look up, I think. We just go to our handy-dandy periodic table. I don't have one right here on the screen, but I'm going to get the values for you here. So first thing is hydrogen, right? And we want the molar mass. That's the number at the bottom on the periodic table. And there are 2 hydrogens, and they're 1.0079. Okay, got that right? Okay. 1 mole of hydrogen will be 1.0079 grams, but I have 2 moles of hydrogen for my molecular mass. You'll see where I'm headed in just a minute. Okay. Now I've got an oxygen in water, because I'm just looking at H2O. I'm not looking at the one up on top here. Okay. 1 oxygen This one I have memorized, and you probably will too if you haven't already. 15.9. Oh, good grief. But my handwriting, on the other hand, that's completely different. 15.999 grams per mole. Okay? And there's only one of those. So we can take those two, we can add them up. Wish you were here, you could add them up for me. Okay. 1.0079. Okay. Times 2. Okay. And then 15. I can't see everything I'm doing right now. 15.999. Okay. I'm going to add those two together. I was tempted for a second to multiply them from the last video. And that gives me the molecular mass of water. Okay, that's going to be useful. So I'm going to say 18. There are 18.0148 grams per mole of H2O. Okay. By calculator. Okay. Now, armed with that knowledge, I can do a little conversion here. I want to get rid of grams, right? So I'm going to say there are 18041 0. Sheesh. Okay, really, I'm thinking about getting checked for dyslexia. Okay, so let's try that. I'm not joking. 18.0148 grams per mole. Okay. Now wait a minute. I didn't really need to put that down there, did I? 1 mole of H2O, right? Now I could write H2O on each of the top and the bottom, but I don't know why, because they're just going to cancel out. So here's what I'm going to do. The grams cancel out, right? And so the next thing I want to know is joules, right? Now I said that there were 2,000 joules, roughly, per mole in this reaction, right? Okay, so mole is what I want down here, and I said in my ratio that it could be 2057 joules per mole. Well, actually, let me not confuse you. Let me not confuse me would be the nice thing. Okay, I want joules on top because I want my final answer to be in joules, because I said 100 grams of H2O is going to be how many? Well, who knows? How many joules? Is that what I said? I'm starting to lose train of my own thoughts. So that's how it feels to grow old, I guess. I don't know. All right, so here we go. I'm going to say there are 4 moles of H2O, okay, for every negative 2057 kilojoules. Okay. I'm going to try and find the energy released by 100 grams of H2O. I don't know if that was even my original question, but that's what's interesting to me now, so that's where I'm going to go. All right, so let's do it. Now I can just multiply these all across. Oh, one other thing I should have done probably is some unit cancellation. That's going to be this and this, right? I wrote H2O here. I probably shouldn't have because that'll get confusing. All right, let's do it. Calculator. Yes, sir? Okay. I'm talking to a calculator. That's what this, okay, so 100. Okay, no units anymore, right? I'm going to carry the H2O through. 100 grams divided by 18.0148 grams. 148, geez. 148. Oh my goodness. I say goodness, that's not like me at all. I'm more likely to swear. I'll just warn you now. Not that I think I should have to. We're all grown-ups here. And the kids who aren't grown-ups watching this, well, you're smart enough to figure out that swear words won't hurt you. And now your parents hate me. All right, so, okay. Yeah. Now, so I'm going to divide that. Okay, that's this first part. And now I'm going to multiply that by 2057. 2057 times. Holy, what the? That's a little bit shocking to me. All right, well, I think that's only shocking to me because 100 grams, you don't think of 100 grams as very much, but look at the reaction. That gave us negative 1.1418 kilojoules of energy released in the burning of enough propane to create 100 grams of water. And I think I better stop there at the risk of losing your attention. Good luck learning.